This lesson is based on the textbook Modern Welding, 11th edition. If an alternate edition is used of Modern Welding, you will have to look up the chapter that pertains to the material covered. Chapter 5, Shielded Metal Arc Welding Equipment and Supplies. Objectives. Identify the components of the shielded metal arc welding process. Identify the welding processes which use a constant current power source. List 3 methods used in welding machines for creating alternating or direct current. Determine the correct size arc welding leads to use for any required current capacity. Demonstrate the ability to identify electrodes using the AWS Electrode Classification System. Determine the correct shade of welding lens and all other PPE required for the welding being done. Arc welding power source classifications. 3 types of arc welding power sources: alternating current power sources, direct current power sources, combination alternating current and direct current arc welding power sources. An inverter welding power source is a special transformer type machine. It changes incoming alternating current to direct current, then back to very high frequency alternating current. Arc welding power source classifications. Arc welding machines can be classified according to a graph of the electrical output of the machine. Such a visual representation is called the static volt-ampere curve. The general slope of the volt-ampere curve is called the output slope of the power source. An arc welding machine that produces a steep output slope is called a constant current machine, which just happens to be the power source used for shielded metal arc welding, as well as gas tungsten arc welding. Constant current power sources. Arc welding power sources are designed to produce an output that has a nearly constant current or voltage. Welding machines that have a steep volt-ampere curve are known as droop curve machines or droopers. The arc voltage varies with the size or length of the arc gap. Constant current power sources. This illustration shows the steep slope of a drooper or constant current machine. There is a good description of this chart in your textbook. Transformer type power sources. Transformers are constructed of 3 principal electrical components: primary winding, secondary winding, and an iron core. Sounds like a test question to me. You will find a good description of this also in your textbook. Transformer type power sources. The primary winding and secondary winding are not connected in any way. A step-down transformer reduces the voltage and increases the current. A laminated iron core is used as the center for both the primary and secondary windings. Controlling transformer output. Constant current, alternating current transformers are controlled by a variety of methods: solid state, movable coil, movable shunt, movable core reactor, tapped secondary, saturable reactor, and magnetic amplifier. Controlling transformer output. Current can only flow in one direction through a transistor. Some power sources use mechanical or electrical methods to adjust how the primary and secondary transformer windings interact. Controlling transformer output. A movable core reactor transformer uses a primary and a secondary coil. A third coil with a movable core is used to control the current output. Inductive reactance increases the resistance of the secondary circuit. Generator type power supplies. An alternating current welding machine can also be a generator type machine. A generator creates an alternating current electrical current from a mechanical source. The rotor is wrapped with multiple turns of wire. As the wire rotates in a magnetic field, an alternating current is created. Direct current power sources. Direct current arc welding power sources are either the transformer rectifier or the generator type. A direct current constant transformer rectifier may be either a single-phase or a three-phase power source. Direct current power sources. Direct current can flow in one of two directions. Direct current electrode negative, also called direct current straight polarity, or direct current electrode positive, also called direct current reverse polarity. Combination alternating current and direct current arc welding power sources are also available. Inverter arc welding power sources. An inverter power source is a variation of a conventional transformer rectifier machine. Inverter machines use a special type of transistor to produce the high-frequency arc current. The direct current is passed through an inverter switcher. A great advantage of inverters is that they are lightweight and small in size. Inverter arc welding power sources. Another method of obtaining alternating current is to use two power supplies in one unit. This method is called dual source with inverter switching. Cooling for welding power sources. Most arc welding machines are air-cooled. Some machines use forced air circulation. Air passageways must be kept open at all times. The machine should be kept clear of obstructions. Periodically, the case should be removed and the machine cleaned. This is one of the most common issues when a welding machine is not working correctly. Loose connections is another common problem. Arc welding power source specifications. An arc welding machine is described and specified by three factors: rated output current rating, power requirements, and duty cycle. The power requirements are called the rated load voltage or welding voltage. Welding leads. Large diameter, super flexible leads are used to carry current from the welding machine to the work and back. Leads are usually insulated with rubber and a woven fabric reinforcing layer. Connections for leads. Leads are fastened to the welding machine and workpiece by means of insulated or uninsulated terminals. The uninsulated terminals are called lugs. Insulated lead terminals are called connectors. Terminals are connected to the leads by different methods: mechanical, soldering, and brazing. Connections for leads. It is sometimes difficult to use a clamping device on a metal fabrication. A magnetic workpiece lead terminal is available, which permits quick and secure fastening of the lead to the weldment. Notice in the picture the different amperages for the different lead terminals. Also, these can only be used on magnetic material. Electrode holders. The electrode holder is the part of the arc welding equipment held by the operator. Many different styles are available, but they all have similar characteristics. Shielded metal arc welding electrodes. Shielded metal arc welding electrodes have a solid metal wire core and a thick flux covering. They are identified by a series of letters and numbers printed on the electrode itself. Shielded metal arc welding electrodes are produced for welding on many metals and alloys. Electrode covering fundamentals. The flux on the electrode performs many different functions, producing a shielding gas around the weld area, providing fluxing elements and deoxidizers, establishing electrical characteristics, adding alloying elements, and creating a solid coating over the weld. Electrode covering fundamentals. During the arc process, some of the flux becomes neutral gases or reducing gases. The slag coating prevents the air from contacting the hot metal and allows the weld to cool more slowly. Electrodes are often referred to as drag electrodes because they are used with a pull technique. Usually, if there is slag, you drag. This holds true with flux cord arc welding as well. Carbon and low alloy steel covered electrode classification. The carbon and low alloy steel electrode classification number uses 4 or 5 digits. The first 2 or 3 digits represent the tensile strength. In the chart below, the minimum tensile strength of deposited metal is 70,000 psi. If they were 100,000 or more, they would have 5 digits instead of 4. Carbon and low alloy steel covered electrode classification. An electrode number may have a letter and number after the normal 4 or 5 digits. Such a letter and number combination, or suffix, is used with low alloy steel electrodes. Low hydrogen electrodes. Hydrogen has harmful effects on alloy steels. Hydrogen embrittlement, hydrogen cracking. Low hydrogen electrodes deposit a minimum of hydrogen in the weld. The low hydrogen condition is obtained by using a special covering. Carbon and low alloy steel iron powder electrodes. The addition of iron powder to the covering of shielded arc electrodes changes the arc behavior. It also increases the amount of filler metal deposited. Much higher currents can be used to produce welds faster. Corrosion-resistant steel electrodes. Corrosion-resistant steel electrodes are used to weld the different stainless steels. The suffix 15 electrode is used with direct current electrode positive. The suffix 16 is used with either alternating current or direct current electrode positive. Both 15 and 16 are low hydrogen electrodes. The numbering system classification calls out the chemical composition of the electrode. Covered electrodes for cast iron. Cast iron can be welded with cast iron, copper-based, nickel-based, or mild steel arc welding electrodes. A cast iron electrode is designated ECI. Cast iron is very difficult to weld, and there is much preparation before and after welding that takes place to get a good weld. Electrode Care. It is important to follow the manufacturer's recommendations for electrode use and care. Electrodes must not be used after being exposed to dampness. It is important to label and store all electrodes in carefully marked bins. Power source remote controls. Welders often need to make changes in polarity and welding machine adjustments. Several manufacturers provide remote control devices that may be kept near the operator. The ability to adjust the machine constantly saves time and results in better welds. Power source remote controls. This illustration shows a remote amperage adjuster. If this is not available, you can change the amperage slightly. A longer arc will increase your amperage, and a shorter arc will lower your amperage. Weld cleaning equipment. It is very important that the base metals be cleaned prior to welding. Insufficient cleaning between passes could result in slag inclusions as well. Shields and helmets. Proper personal protective equipment is required at all times. An arc welding helmet is used to protect the face and eyes. OSHA requires the use of a hard hat with the arc welding helmet on construction sites. Shields and helmets. Some helmets have auto-darkening lenses, as shown here. Variable shade lenses are also available. Helmets with solar panels like this one will save on batteries. There are also many different paint schemes on helmets and different types of helmets. Special arc welder clothing. Clothing should be inspected to eliminate any place where the metal can catch and burn. Open pockets are especially dangerous. Clothing worn while welding, other than leathers, should be of heavy material. Easily ignited material should not be carried by the operator while welding. Butane lighters can explode and should not be carried when welding. Safety. When working in the overhead position, wear a jacket or cape to protect the shoulders and arms. Wear a cap or hooded helmet to protect the head and hair. Wear high-top shoes or boots, gloves, and long pants without cuffs. Leather is the best form of material for protection. Safety glasses are also required. Hearing protection not only protects from loud noises, but will prevent sparks and spatter from entering the ear canal.